Hi, I'm Dr. Laura Wilson. I'm the curator of paleontology here at the Sternberg Museum of Natural History, and thank you for joining us for a new way to museum. Today I'm going to talk about birds, and if we think about what a bird is and we look out in the sky around us, then you have a couple of characteristics that come to mind, things like flight and feathers. So we have our macaw here with the gorgeous colored feathers. It is a flighted bird. Of course, we do have some birds that are unable to fly, like a penguin or an ostrich or an emu, but they still have the obvious characteristics of the wings and the feathers. I'm a paleontologist, which means that I study fossils. So most of the time we don't have things like feathers preserved in the fossil record, and behaviors such as flight are very difficult to understand and fully confirm. So we have a tendency to use the skeleton as more clues as to what makes up a bird. So I have my lovely chicken model here to help demonstrate of some of the bone characteristics that we have for birds. So because one of the things that we associate with birds is flight, there are a lot of adaptations, so special characteristics of the skeleton that do make flight possible. So one of the things that we have, you can't really see here, is hollow bones. And so the bones actually aren't thick all the way through, but are very thin, and this makes the skeleton light. We also see a lot of fusion of bones. So this is when two or more bones join together into one functional unit. So we can look here at the wings, and so this is actually the wrist in this area, and so you don't see the 5 fingers that we have on the human hand, and you don't see all of the individual finger bones that we have as well. Rather, they have a reduction in the number of fingers. They just have 3 fingers, and then they get a lot of fusion or the joining together of different bones. We see that in the leg as well. The lower leg bones, the tibia and the fibula, actually join together and fuse into one bone. And you can also see that in the hip region as well, where a lot of the hip vertebrae and the hip bones fuse together in what we call the synsacrum. Other characteristics that we associate with birds are things like this large keeled sternum. This is where all of those flight muscles attach. So think about your Thanksgiving dinner with your turkey or eating chicken one night. This is where all that white meat breast muscle attaches. And so these are all the muscles that are very powerful to power that flight stroke. And then one of the things that is also very famous on a bird and that we associate with them is this bone right here. This is called the furcula, or what we call kind of colloquially the wishbone. So this is what you and your friend or your sibling will grab and break off for who gets to make the wish. So this is actually the fusion of the clavicles, which are kind of in the neck and shoulder region. And then they fuse together in birds into what we call the furcula. If we look at the skull, we look at other things as well. So they have a toothless beak. We do not have any birds that are living today with teeth in their skull, but they do have this kind of hard keratin layer, so like what our fingernails are made out of, on their beak, as well as a lot of reduction of bones. So these are all things that we look at, in addition to many other characters, to help us understand what a bird is and how that bird functions, either for flight or in some cases swimming and running. When we talk about the fossil record and the fossil record of birds and the evolution of birds, things get a little bit more difficult to identify. So we now know that birds are dinosaurs. So I have my trusty dinosaur skull here. So I say birds are dinosaurs the same way that a cat or a horse is a mammal. So the ancestor to a bird was a dinosaur. So because of this, paleontologists have a tendency to talk about avian and non-avian dinosaurs. An avian dinosaur is a dinosaur that is a bird, like a chicken or a pigeon or a penguin or something like that. And then we have a non-avian dinosaur, so a dinosaur that is not a bird, so a T-Rex or a Triceratops or an Edmontosaurus or something like that. So as we get further back into the fossil record in the Jurassic and Cretaceous 200, 250 million years ago, it becomes a lot more difficult to understand what a bird is and what a bird isn't, or this difference between an avian and a non-avian dinosaur. So here I have as an example Archaeopteryx. So this is a cast of the Berlin specimen of Archaeopteryx and is generally considered to be the first or one of the first birds. So this is something where we stop calling it a non-avian dinosaur and call it an avian dinosaur. And we start seeing more bird-like features than we see kind of ancestral dinosaur-like features. So looking at Archaeopteryx here, we do see outline of feathers. So when Archaeopteryx was first found, it was found with feathers. It was actually found right after Darwin published on the origin of species. And so this huge example of this transition, this evolution from dinosaurs to birds. So feathers was a big indicator at first for what was a bird and what was not a bird in the fossil record if we were lucky enough for them to preserve. For better or for worse, we now have a huge number of dinosaurs and all different groups that have feathers but are not birds. So even juvenile and baby Tyrannosaurids have been found with feather-like filaments, and a T-Rex is not a bird. But we do see other things. So we see some of the transitions in the skull. We see the beginning of a beak, though Archaeopteryx does still have teeth. We see a lot of the fusion of these different bones. So we see the reduction in the number of fingers. We see the fusion in the wrist bones. We see changes. We see a furcula. We have hollow bones. But we still have things like a long tail, which is very dinosaurian and not very bird-like. And so a lot of these clear lines that we think we know what we're talking about when we're talking about modern birds get kind of muddied when we talk about fossil birds, because things like T-Rex does have a furcula. It's not functioning the same and it's not looking the same as a bird T-Rex, but they still have the fusion of the clavicle bones. 3 fingers in the hand actually goes back to the first dinosaur that we know of in the Triassic time period. And so we start to kind of muddy the water as to what a bird is and what a bird isn't. And it's actually one of my favorite questions to ask my paleontology students is, what is a bird? And it's a very difficult question to answer when we start talking about the fossil record. But we can start putting pieces together to look at the evolution or transition of different characters for something that looks more velociraptor-like to something that looks more hawk or eagle-like. And then things become a little bit more clearer as we move closer to the present in the fossil record. So I've spent the bulk of my career, at least 13 or more years, studying a group of birds called Hesperornithiforms, or Hesperornis. And this is a bird that, for a bird, is fairly common in the Western Interior Seaway that covered North America 85 million years ago. This is a really cool bird because there are still a few dinosaur-like characteristics that it has. It still has teeth, for example. It's one of the last toothed birds before we transition to modern birds without teeth. But it has a lot of specialized adaptations that give us insight into its lifestyle. So the same way we can look at the wing structure of a bird that can fly and determine what the flight stroke may look like, we can look at characteristics of something like Hesperornis and try to determine how it moved. And there are a couple of key characteristics that we can look at within Hesperornis. So let's start with the wings, since that's one of the most iconic characteristics of a bird. So if we look at Hesperornis, we see a tiny stunted wing. It actually only has the upper arm bone, the humerus, and is missing all of the lower arm bones, the wrist bones, and the fingers. Putting this together, we know that this bird most likely or definitely was not using its wing to fly. So then that begs the question of how was it moving around? Well, we can then look at the legs to determine the answer to this question. And what we see is we see very long legs. While we do have kind of a short thigh bone or femur, we have the very long lower leg bone. So the tibia and the fibula, where they're fused together, very long toes as well. And so this is an animal that had very powerful legs that they used to kick through the water. So they weren't flying underwater like a penguin, they weren't flying in the air like a hawk, they weren't running on land like an ostrich or an emu, but they were kicking underwater like a loon or a grebe or a cormorant, which are some of our what we call foot-propelled divers today. We find it in marine sediments within this western interior seaway. So we have a good idea that it was spending most of its life in the water, kicking around. There are other things that are really interesting about this in terms of, like I mentioned, it's the last bird to have teeth, and as well as it has this very long hip region, which again is going to be really important for muscle support to support those legs. So this is an animal that was very successful in the water, but probably couldn't function on land very well at all. So we can actually look at its sister taxon, or one of its most closely related relatives of Ichthyornis. So Ichthyornis is another bird found in the western interior seaway, but you can see that the anatomy of this bird is very different from Hesperornis. It has fully developed wings, and so we know that this bird was flying. It doesn't have the leg proportions that we see on Hesperornis. And so while Hesperornis is probably swimming underwater like a cormorant to hunt down fish or squid or something like that, Ichthyornis, on the other hand, was probably more like a tern or a gull that would fish and get food out of the water, but would do so while flying or while sitting on the water and then be able to take flight off the water. And so we can put together a lot of what we know about modern birds and take this into the fossil record to determine not only what is a bird, but which types of birds are most closely related, how the transition from a very dinosaurian, velociraptor, T-Rex type anatomy transitioned to what we think about with modern birds today. And then we can also look at examples of modern birds and put this towards understanding the behavior and the ecology of extinct birds. So these are a lot of things that we can do, kind of pairing the present with the past to get a better understanding of what past life looked like and actually what future life may look like as we move forward. So thank you for joining us today for a new way to museum, and please feel free to leave any questions in the comments and we'll try to get back to those. Thank you.
Thanks for joining us in A New Way to Museum with the Sternberg Museum of Natural History. If you enjoyed this video, like it and subscribe to our channel. Hit the bell for notifications when we release a new video. Support us on Patreon for early access and exclusive content. You can also follow us on all our social media. Links are found in the description. Thanks for watching, and follow your curiosity to new discoveries.